Hi. Since several of you guys asked me the question about the recitation 1, the example 3, about how to use R, so I'm gonna make this video. Hopefully it will help you how to do the example 3. So I will walk you through the code line by line. Our starting point is, I assume you have the R and R Studio installed in your computer, or you're gonna use a university computer which already have the R and R Studio installed. If you need help for installation, please refer to the canvas. Remember, I put a module about the R and R Studio here. Okay, so please go there and then try to install the R and R Studio by yourself first. If you do need help, and then please let us know. So our starting point for this video is, I assume we have the R and R Studio ready to use. And also, I would suggest you would create a folder like I'm doing here, save all the files, especially the data set, and then also the R code right here in the same folder. For example, I put as a recitation and week 1. Okay, right here. All right, now let's just walk through the code one by one. So the first step, we gotta import the data file into the R, because the data file is the Excel. How to import the Excel data into the R? The easiest way I would do this way, because if you go to hit the tab, and then the tab command import data set and from Excel. Take a look right here. Yes, whenever it asks you to install this package, you just hit yes. Okay. Right. Yes. Now, after this one pops up, you just browse, go to the folder where the data set is saved. I think it's here for my case. Right? Yes. Okay. Now take a look. From here, basically you can see the data set from the data preview, and then you just hit import. See, you can see this data set. But here's something I want to say something about R. If you open the R Studio, right, you are supposed to see these 4 panes. Okay, this is 1, this is the 2, and then 3, and then 4. Mainly we are gonna deal with these 2 panes. The first one is this script pane. That's where you're gonna see the R code and also the data view, right? And also the console pane. The console pane is where the R codes are gonna execute it on. You see right here? Right here. See, just now we asked the R to import the Excel data file. That's how you will see the results right here. And the environment and the help pane, they are ancillary, because this one, the environment basically shows us the data set, right here, the variables. Yes, this imported one, right? Okay. And then the help, basically we're gonna if you need help with the code, that's why you're gonna get help here. Also, the another one is the package, because sometimes we have to install the package, then this is where you should go. So please keep in mind, the RStudio has 4 panes, okay? So we do the script pane, console pane, environment pane, and then the help pane mainly, okay? Alright, now let's go to the code. So yes, this one is easy. Yes, as I said just now, to import the Excel data file into R, this is the easiest way if you do not know the code, right? But if you know the code, here is the way we can just do in this way. Because this way, first of all, you use the library. Library, basically you're gonna call this package to use, because this function is in this package. And in order to do that, because you gotta tell R where to find this data set, right? But to make this work, we need to do one more step. We go to the session and then set work directory, and then put as the source file location. What does this mean? Source file location basically say we put our work directory the same as where this our script or our code is saved. So basically is this folder right here. Okay, we put right there. Okay, this as the work directory, because you gotta tell R where to find this data set. Alright, okay. Now this is very neat. After I like this part, you just highlight this code and then you run it. Yes, whenever this error means the path problem, we can always check, right? Because I think we should source file location. You see right here. Now you see, yes, just now I forgot to hit the tab. Now it should be fine now. Highlight this code and then run it. Here you go. So this data set, we imported this data set, right? And then now we define as a new name ex27, and then use the view function. We can take a look at this data set. This is very nice, right? Because you can see here is basically the same thing as you take a look at the Excel file by the Excel. Here use R, we can do the same thing to take a look at the spreadsheet. Okay, so alright, this is the code, the data set we'll work on. Okay, so let's take a part A, count numbers of males and females. Now if you take a look at this data set, it has a sex variable. For sex variable, you have male and female. Of course, for little observations, we could just eyeball, right? But take a look at this data set. It's kind of big, right? It's a lot. Yes, I think, yes. You see, it's over 300. There's no way we can count just by fingers. Okay, so that's why we have use the function length. Length basically tells us how many observations for that variable. So basically we can do the same thing here. We can just say, what is the length? Let's try one. Length, right? And then ex27, right? And then we use a function. We just say, let's take a look at income variable. Okay, we highlight it and then run it. So the length of this income variable is 890. That's basically say we have 890 observations for this data set. Okay, this is a lot. It's so big, right? Alright, now it asks us among these 890 observations, how many observations are made for male, how many are gonna made for female. That's why we just split this whole data set as the male, right? Use this $sign, the sex variable equals M. And then the same thing, we say sex variable equals F. Here we're gonna be careful. We use double quote because this male and female are characters. So the sex variable is what kind of variable? Is categorical variables, right? So also, don't forget this quote sign. Okay. Now if we run this two, you're gonna tell us how many males and how many females in the data. Let's run. See, 508 is male, 382 is female. If you add these two numbers together, you get 890. Okay, so we're done with part A. Now let's look at part B. Part B asks us find the percentage of males and females who are married. Remember, go back to the data set. You see there is a variable is called married. M means not no, Y means yes, right? And then Y. So how can we do that? So we're gonna use the which. So you can see here is the male and then married, right? And then we use and because we want to know both male and married, right? It's like an intersection. That's exactly the male and who are married and the female who are married. You see, female married, yes. And then divided by total number of male, as we get from part A, and the total number of female we get also from part A. Okay, and then times 100. That's the way we're gonna get the percentages, right, of married male and married females. So if we run this code, we should get 2 percentages. You see right here, about 66% and 64.9%. Okay, so if we keep 2 decimals, you see this is the percentage of married male is 66.14. Percentage of married female is 54.92%. Okay, and then part C asks us the 10 individuals with the highest income, find the number of who are married male. So this question is very interesting. First of all, we have to sort this income variable, right? You can see we order this income variable with the decreasing order. What do I mean by decreasing order? We put the higher income at the beginning and then lower income accordingly follow the decreasing order. Now if we sort this data and then we run it, right? And then we take a look at this data set, view. Okay, now we see this sort data. So now you take a look, right? See this income variable, 147 is the largest one, and then 140 is smaller, smaller, smaller. Okay, all the way to the smallest one. Okay, yeah, right here. Just go a little bit. Yes, let's go. Keep going. Right. Yeah. See the income 22, the smallest one. This one is 147, the largest one. Okay. The question asks about the 10 individuals with the highest income. So we sort this one. We pick this sorted data with 1 to 10. Actually, for this first 10, we can eyeball it here. Right here, sorted data from 1 to 10, right here. Okay, and then we want to find 10 individuals with the highest income. Find the number who are married males. So first of all, we need to say how many of them married. Y, right? Because okay, we have how many Y's? 8 Y's, because 2 N's, right? That means 8 Y's means yes, married. And then how many males? Okay, we have female only 2 or 1, 9, right? We have 9 males. Among these 9 males, how many of them are married? You see this one, the first one, second one, third one, fourth one, fifth one, sixth one, and the 7th one. Okay, just by counting, by eyeballing, we have 7. So, but if we run this code, the R will tell us a number which is also 7. You see, use R to do it, right? Because it's much easier. Alright, now let's take a look at part D. Find the highest and the lowest income of males and females by inspecting the sort data. So here we have to find the highest income, lowest income for both the male and the female. That means we have to sort this data by 2 variables, not only by income but also by the sex data. Sex variable is decreasing. Is true that basically for the income variable is a numerical variable, so numbers from the largest one to the smallest one. But how about the sex? Because this sex variable only has 2 categories, M and F. Whenever we put as the decreasing equals, that's exactly as what we mean by alphabetic order is increasing. Okay, so decreasing is alphabetic order is first start with A and then B and C, right? And then whenever we put the decreasing as equal to 2, that means this order start with the Z. It's different. But here we only, as we see, this only two letters, right? M and F. So F goes first if it's increasing order. But now it's decreasing order, then M goes first. Okay. Now if we run this code, run it, and then yes, we define this as the sort data 2, and then we view it. Take a look at this. That's exactly, you see right here, income variable, sex variable. So we put the male in the first category, and then female in the second. Okay. Among the male and the female, the income variable is sorted with the largest one to the smallest one. The same thing for female. Okay. So with that, we could just find the highest value and the lowest value for male and female. We can eyeball it here. You see, for the male, the highest value is 147. What is the smallest one? You go all the way down. right, all the way down. You see, right here, we have 509 males. So the smallest income variable value is 35. And then go to the female, and then 138 is the largest one. And then what is the smallest income for female? 22. So if you sort this data set by the income variable and the sex variable, then we could find solutions for the part D. Okay. And then for part E is even harder. Find the highest and lowest income for married and unmarried male. So here we have the sorted the data with the sex variable, that because we only consider the male, and also sorted with the married, yes or no, and then income variable. That means we have the order sort this data set by 3 variables and then decrease in order. If we do that now, just imagine, right? You sort and then view. See now with sex variable and the married variable, male and married, okay. See, also male unmarried, not married, okay, this one. And then the same thing for female. You have female married, right here, and then female unmarried, not married. And then since the data is sorted by both the sex variable and the marriage status variable, then we could find the highest and lowest values of the corresponding subgroups, right? Alright, for the part D and E, to find the, if you are not that comfortable by check this sorted data set, we could ask R directly to do it. Just tell us what is the largest value, what is the smallest value. So this max is the function to find the largest value. Minimum is the function to find the smallest one. Now you have to tell R where to go, right? Because here you just say, among all the males, means the sex variable equals M, what is the max, and then what is the minimum. Okay, this is the max income for male, max income for female, and then the same thing for female right here. And then what if we want to find the max income for married male? You can see this sex equals M and the married equals Y. You will use the max and then use the minimum. This is for married male, and for unmarried male, you can see right here, we pick the married equals capital N. So if you run this code, the R can tell us these numbers directly. So if you run this code, right, and then you are supposed fill these tables with the result from R, okay, right here. Of course, for the part A, and we could use this table command. The same thing. We just tab this sex variable. You just tell us how many female and how many male. And then if we want to get the so-called this table, actually this is the cross. What kind of table is this? It's kind of like the we just table this sex variable, tab this sex variable, and then also with the married variable. So both variables are quantitative. That's exactly we just learned from lecture 2. Is this exactly tells us the contingency table, right? Because we want to know the relationship between two quantitative variables. And then further, we could just use this so-called prob table can give us the relative frequencies. Okay, see, this is the code. Alright, I hope this video can help you to work with R and RStudio. If you have any question, as I said at the beginning, please let me know. Thank you.